Hello everyone, welcome to NCERT Science. We are studying class 6 Science, chapter number 3, Separation of Substance. In our daily life, there are many instances when we notice a substance being separated from mixture of materials. Tea leaves are separated from the liquid with a strainer while preparation tea. Grain is separated from stalks while harvesting. Milk or curd is churned to separate the butter. When given cotton to separate its seeds from the fibers, perhaps you might have eaten salted dalia or poha. If you found that it had chilies in it, you may have carefully taken them out before eating. Suppose you are given a basket containing mangoes and guavas and asked to separate them. What would you do? Pick out one kind and place them in a separate container, right? Seems easy, but when it is the material we want to separate are much smaller than mango or guava. Imagine you are given a glass of sand with salt mix in it. Impossible when even to think of separate salt from this mixture by picking out grain of sand by hand. But why would we need to separate substance like this at all is what Paheli want to know. Activity 1. In column 1 of table 3.1 are given a few process of separation. The purpose of separation and the way of separated components are used in the mentioned in column 2 and 3 respectively. However, the information given in column 2 and 3 is jumped up. Can you match each? Separate stones from rice. Remove impurities or harmful components. We away the impurities. Churning milk to obtain butter. To separate two different useful components, we use both the components. Separate tea leaves. To remove non-useful components and we threw away the solid components. Process with its purpose and the way of separated component are used. We see that before we use a substance, we need to separate harmful or non-useful substance that may be mixed with it. Sometimes we separated even useful components if we need to use them separately. The substance to be separated may be particles of different sizes or materials. These may be in any three state of matter: solid, liquid or gas. So, how do we separate substance mixed together if they have so many different properties? Method of separation. We will discuss some simple method of separation substance that are mixed together. You may come across some of these methods being used in the day-to-day activity. Handpicking. Activity number 2. Bring a packet of food grain purchased from a shop to the classroom. Now spread the grains on the sheets of paper. Do you find only one kind of grain on the sheet of paper? Are there pieces of stone, husk, broken grain and particles of any other grain in it? Now remove with your hand the piece of stone, husk and other grain from it. This method of handpicking can be used for separating slightly larger sized impurities like the pieces of dirt, stone and husk from wheat, rice or pulses. The quantity of such impurities is usually not very large. In such situation, we find that handpicking is a convenient method of separating substance. Threshing. You must have seen bundle of wheat or paddy stalks lying on fields after harvesting the crops. Stalks are dried in the sun before the grain is separated from them. Each stalk has many grain seeds attached to it. Imagine the number of grain seeds is hundreds of bundles of stalks lying in the field. How does the farmer separated grain seeds from those bundle of stalks? One may pluck mangoes or guavas from the trees, but grain seeds are much smaller than mangoes or guavas, so plucking them from their stalk would be impossible. How does one separate grain seeds from their stalks. The process that is used to separate grain from stalks etc. is threshing. In this process, the stalks are beaten for free the grain seeds. Sometimes threshing is done with the help of bullocks, and machines are also used threshing large quantities of grain. Winnowing. Activity 3. Make a mixture of dry sand with sawdust or powdered dry leaves. Keep this mixture on a plate or a newspaper. Look at this mixture carefully. Can the two different components be made out easily? Are the size of particles of two components similar? Would it be possible to separate the components by handpicking? Now, take your mixture to an open ground and stand on a raised platform. Put the mixture in the plate or sheet of paper. Hold the plate or the sheet of paper containing the mixture at your shoulder height. Tilt it slightly so that the mixture slides out slowly. What happens? Do both the components sand and sawdust for powder leaves fall at the same place? Is there a component that blow away? Did the wind manage to separate the two components? This method of separating components of mixture is called winnowing. Winnowing is used to separate heavier and lighter components of mixture by wind or by blowing air. This method is commonly used by farmers to separate lighter husk particles from heavier seed of grain. Husk particles are carried away by the wind. The seed of grain gets separated and form a heap near the platform for winnowing. The separated husk is used for many purposes such as fodder for cattle. Sieving. Sometimes we may wish to prepare a dish with flour. We need to remove impurities and bran that may be present in it. What do? We use a sieve and pour the flour in it. Sieving allows the fine flour particles to pass through the holes of the sieves while the bigger impurities remain on the sieve. In a flour mills, impurity like husk and stones are removed from wheat before grinding it. Usually a bag full of wheating is poured on the slanting sieves. The sieving removes piece of stone, stalk and husk that may still remain with heat after threshing the winnowing. You may have also noticed similar sieving being used at construction site to separate pebbles and stones from the sand. Activity 4. Bring a sieve and small quantities of flour from home to the class. Sieve the flour separated any impurities in it. Now make a fine powder of chalk pieces and mix with it the flour. Can we separate the flour and the powdered chalk by sieving? Sieving is used when components of mixture have different sizes. Sedimentation, decantation and filtration. Sometimes it may not be possible to separate components to a mixture by winnowing and handpicking. For example, there may be lighter impurities like dust or soil particles in a rice or pulses. How are such impurities separated from rice or pulses before cooking? Rice or pulses are usually washed before cooking. When you add water to these, the impurities like dust particles get separated. These impurities go into water. Now what will be sink to the bottom of a vessel, rice or dust? Why? Have you seen that the vessel is tilted to pour out the dirty water? When the heavier component in the mixture settle after water is added to it, the process is called sedimentation. When the water is removed, the process is called decantation. Let us find as a few other examples or mixture that can be separated through sedimentation and decantation. The same principle is used for the separating a mixture of two liquids that do not mix with each other. For example, oil and water from their mixture can be separated by this process. If a mixture of such liquid is allowed to stand for some time, they form two separate layers. The component that forms the top layer can then be separated by decantation. Let us again consider a mixture of solid and liquid. After preparing tea, what do you do to remove the tea leaves? Usually we use strainer to remove tea leaves. Try decantation. It helps a little, but do you still get a few leaves in your tea? Now pour the tea through a strainer. Did all the tea leaves remain in the strainer? This process is called filtration. Which method of separating tea leaves from prepared tea is better, decantation or filtration? Let us now consider the example of water that we use. Do all of us at all time get safe water to drink? Sometimes water supplied through tap by the be muddy. The water collected from ponds or river may also be muddy, especially after rains. Let us see if we can use some method of separation to remove insoluble impurities like soil from the water. Activity 5. Collect some muddy water from a pond or a river. If it is not available, mix some soil to water in a glass. Let it stand for half an hour. Observe the water carefully and note your observation. Does some soil settle at the bottom of water? Why? What will you call this process? Now slightly tilt the glass without disturbing the water. Let the water from the top flow into another glasses. What will you call this process? If the water in the second glass is still muddy or brown in color, now filter it. Did the tea strainer work? Let us try filtering the water through a piece of cloth. In a piece of cloth, small holes or pores remain in between the woven threads. These pores in a cloth can be used as a filter. If the water is still muddy, impurities can be separated by filter that has even smaller pores. A filter paper is one such filter that has very fine pore in it. So the step involved in using a filter paper. A filter paper folded in the form of cones is fixed onto a funnel. The mixture in these pores on the filter paper. Solid particles in the mixture do not pass through it and remain on the filter. Fruits and vegetable juice are usually filtered before drinking to separate. The seeds are solid particles of pulp. The method of filtration is used also in the process of preparing cottage cheese paneer in our home. You might have seen that the making paneer, a few drops of lemon juice are added to milk as it's boiled. This gives a mixture of particles of solid paneer and liquid. The paneer is then separated by filtering the mixture through a fine cloth or strainer. Evaporation. Activity 6. Add 2 spoons of salt to water in another beaker and stir it well. Do you see any change in the color of water? Can you see any salt in the beaker? After stirring, heat the beaker containing the salt water. Let the water boil away what if left in the beaker. In this activity, we use the process of evaporation to separate a mixture of water and salt. The process of conversion of water into its vapor is called evaporation. This process of evaporation takes place continuously whenever water is present. Where do you think salt comes from? See, water contains mainly salt mix in it. On this salt is the common salt. When seawater is allowed to stand in shadow pits, water gets heated by sunlight and slowly turn into water vapor through evaporation in a few days. The water evaporates completely, leaving behind the solid salt. Common salt is then obtained that this mixture of salt by further purification. Use or more than one method of separation. We have studied some method for separation of substance from their mixture. Often one method is used is not sufficient to separate the different substance present in a mixture. In such a situation, we need to use more than one of this method. Activity 7. Take a mixture of sand and salt. How will we separate these? We already saw that Handpicking would not be practical method for separating this. Keep this mixture in a beaker and add some water to it. Leave the beaker aside for some time. Do you see the sand settle down at the bottom? The sand can be separated by decantation or filtration. What do the decanted liquid contain? Do you think this water contained the salt which was there in the mixture at the beginning? Now we need to separate salt and water from the decanting liquid. Transfer this liquid to a kettle and its lid. Heat the kettle for some time. Do you notice a steam coming out from the spouts of the kettle? Take a metal plate with some ice on it. Hold the plate just above the support of the kettle as shown in figure 3.13. What do you observe? Let all the water in the kettle boil off. When the steam comes in contact with the metal plate cooled with ice, it condenses and forms liquid water. The water drops that you observe falling from the plate were due to condensation of steams. The process of conversion of water vapor into the liquid form called condensation. Did you even see water drops considered under a plate that has been used to cover a vessel containing milk that has just been boiled? After all, the water has evaporated. What is left behind in the kettle? We have thus separated salt, sand and water using process of decantation, filtration, evaporation and condensation. Paheli faced a problem while recovering salt mixture with sand. She has mixed a packet of salt in a small amount of sand. She then tried the method suggested in activity 7 to recover the salt. She found, however, that she could recover only a small part of a salt that she had taken. What could have gone wrong? Can water dissolve any amount of substance? We found that many substances dissolve in water and form a solution. We say that these substances are soluble in water. What will happen if we go on adding more these substances to a fixed quantity of water? Activity 8. You will need a beaker of a small pan, a spoon salt of water. Pour half a cup of water in the beaker. Add 1 teaspoon of salt and stir it well until the salt dissolves completely. Again add a teaspoon of salt and stir well. Go on adding salt on teaspoon at a time and stir. After adding a few spoons of salt, do you find that some salt remains undissolved and settle at the bottom of a beaker? Yes, this means that no more salt can be dissolved in the amount of water we take in. The solution is now said to be saturated. Here is a hint as to what might have gone wrong when Paheli tried to recover large quantity of salt mixed with sands. Perhaps the quantity of salt was much more than that required to form a saturated solution. The undissolved salt would have remained mixed with the sand and could not be recovered. She could solve her problem by using a larger quantity of water. Suppose she did not have sufficient quantity of water to dissolve and the salt in a mixture. Is there some way that water could be made of dissolve with more salt before the solution gets saturated? Let us try and help Paheli out. Activity 9. Take some water in a beaker and mix salt in it until it cannot dissolve any more salt. This will give you a saturated solution of salt in water. Now add a small quantity of salt to this saturated solution and heat it. What do you find? What happened to the undissolved salt in the bottom of the beaker? Does it dissolve now? If yes, can some more salt be dissolved in this solution by heating it? Let this hot solution cool. Does the salt appear to settle at the bottom of beaker again? The activity suggested that large quantity of salt can be dissolved in water on heating. Does water dissolve equal amount of different soluble substance? Let us find out. Activity 10. Take 2 glasses and pour half a cup of water in each of them. Add a teaspoon of salt to 1 glass and stir till the salt dissolve. Go on adding salt 1 teaspoon at a time till the solution saturated. Record the number of spoon of salt that dissolve in water in table 3.2. Now repeat the sum activity with sugar. Repeat this with some other substance that are soluble in water. What do you notice from table 3.2? Two different substance in different amount. We have discussed a few methods of separating substance. Some of these methods of separation presented in this chapter are also used in the science of laboratories. We also learned that the solution is prepared by dissolving a substance is a liquid. A solution is said to be saturated if they cannot dissolve more of the substance in it. Keywords: churning, condensation, decantation, evaporation, filtration, handpicking, saturated solution, sedimentation, sieving solution, threshing, winnowing. If you like my video, please like, share and subscribe my channel. Thank you so much.